Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the physics topic, efficiency. I know many of you guys have this topic efficiency coming up for exams, so hopefully this video can help you all in order to understand how to solve these type of questions. So do watch the whole video. I might give in some bonus tips here and there. So if you guys have all enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, by the way, this worksheet I got this from a site called Physics and Math Tutor. Is a really good website that you guys can use to do physics questions and all. And yeah, I'm gonna go through each one of these questions, and let's begin with the video. Alright, time codes will also be written down in the description below, so you guys can skip to any question you guys like. And yeah, let's begin with the video. Alright, so the first question states that a student used the apparatus drawn below to investigate the heating effect of an electric heater. Now, as you guys can see, that there's a nice little diagram of the electric heater. Now, before starting the experiment, the student drew graph A. Now, graph A shows how the student expected the temperature of the metal block to change after the heater was switched on. So as you guys can see, that we can see a graph of A with the increase in temperature of the metal block in degrees Celsius, and we can also see the timing. The timing calculations of when the electric heater was switched on. So that's great and all. Now the question is for 2 marks, and we have to describe the pattern shown in graph A. Now, one good tip that you guys can take from this is that no machine is 100% efficient while dealing with efficiency, because they waste some form of energy in the form of heat, sound, etc. Alright, so no machine is 100% efficient, as some wasted energy is usually transferred to useless thermal energy stores. Alright, so that's one good tip that you guys can take down. Now, in order to describe the pattern, you guys can see that as you increase in temperature, the time also increases as well. So you can say that as temperature increases, as the temperature increases and time increases, they are directly proportional to each other. Time increases, they are proportional. They are directly proportional. Alright? Proportional to each other. So that's one good point that you guys can write down. Then you can mention that there is a positive correlation that could also be there in your answer as well. So there is a positive correlation. Alright? This diagram. Now, the main thing while dealing with physics on GCSE or GCSE questions is writing down the keywords. It's really critical that you guys write it down. It's very important. You guys can also mention that there's a linear relationship and that temperature and time are proportional to each other. Right, so now this is for 2 marks so that you guys can write for this type of question. Let's move on to the next question. Alright, question part 2 of question 1 states that the student measured the room temperature. He then switched the heater on and measured the temperature of the metal block every 50 seconds. The student calculated the increase in temperature of the metal block and plotted graph B. Now you guys can see again there's a graph, and it shows us the increase in temperature of the metal block in degrees Celsius along with the time as well. So that's the same case as graph A. Now after 300 seconds, graph B shows the increase in temperature of the metal block, which is lower than the increase in temperature expected from graph A. So as you guys can see, the graph A is more likely a straight line graph, but something about that straight, and this graph is more turning towards a curve upwards. Alright, so we can mention one reason why. Now there could be many reasons to this. Like I said from the start of the video, is that no machine is 100% efficient, as they waste energy in the form of like useless thermal energy stores in the form of heat and sound. Right, so you can mention that there's an energy transfer from the block to the surroundings as they waste energy. Alright, so you can mention that the energy transfer is from the block to the surroundings as wasted energy, to the surroundings as wasted energy. Now this is something that you guys can write down for 1 mark. You can mention also that there's a lost, you can mention that loss for transfer, you can mention air for surroundings, or you can mention that some of the energy is used to warm the heater, or the metal block itself is not insulated in this case. Alright, you can mention those points. Now let's move on to a bit of calculations for this question. Is that the power of the electric heater is about 50 watts. You have to calculate the energy transferred to the heater from the electric electricity supply in 300 seconds. Now there's a nice little formula triangle that I would like you guys to remember, is that formula triangles are a nice little illustration of using the formulas. Alright, so there's a formula called EPT, where the energy transfer is equal to the power times the time. So you have energy transfer is equal to power in terms of 50 watts times 300 seconds, which is also mentioned in the question. So you can do that, and you can multiply 50 times 300 seconds, which you get, by the way, I'm going to cut down the values actually. We're going to have 50 times 300, so it's much easier for you guys to understand. You have 15,000 joules. Now this is going to be your answer for this type of question for 2 marks. You got to show your workings, really critical here. In this case, you have 15,000 joules. All I did was 50 watts times 300 seconds, following the rule of the formula triangle. And the formula itself states that energy transfer is equal to power times time. So you have 15,000 joules in this case. Alright, let's move on to the next question. The next question states that the student uses the same heater to heat blocks of different metals. Each time the heater is switched on for about 300 seconds, each block of metal has the same mass but a different specific heat capacity. So as you guys can see there, there's aluminum, iron, lead. Now I feel these questions are very similar to the previous video, so do check that out as well. Talks about I think some question walk through into energy transfers. Alright, so you have aluminum, you have iron, you have lead. Now you can see that there are different specific heat capacities. In this case, you have to draw a ring around the correct answer of which one of the metals will heat up the most. So since you know that lead has the lowest specific heat capacity in joules from the table itself, as we can observe that lead has the lowest, we know that lead is one of the metals which will heat up the most. So we're going to just draw a circle around lead. That should be your answer. Alright, now we have to give a reason why. The reason is because lead needs, we have to give in amounts of energy needed to heat the metal block. Lead needs the least amount of energy needed to raise temperature of about, let's say, 1 degree at 1 degree Celsius. So you're going to mention that lead needs like a least amount of energy needed to raise about temperature about 1 degree Celsius. You mentioned that for 2 marks. 1 mark is for drawing a circle for the correct answer, and the other mark is for the reasoning. You can also mention that it needs less energy to heat it by the same amount. Okay. Now let's move on to the next question. Now the next question shows us a solar-powered aircraft. As you guys can see that the aircraft has no pilot. You can see solar cells, you guys can see a propeller, you guys can see an electric motor as well. Now on a summer day, there's about 175,000 joules of energy that is supplied to the aircraft's solar cells every second. Now the useful energy transferred by the solar cells is about 35,000 joules every second. Now what you're going to do is you're going to use the equation in the box to calculate the efficiency of the solar cells. Now this is a question that could come up in your exam, like this style of efficiency questions. Alright, so you have to show clearly how you work out your answer for about 2 marks. So as you guys can see is that the formula for efficiency is useful output energy transfer divided by total input energy transfer, or like technically the energy that is supplied to the device. So now we have to make out from this question itself which one is the useful energy and which is the input total energy supplied to the device. So as you guys can see that 175,000 joules of energy is supplied. So that keyword supplied shows us that 175,000 would be divided at the bottom of this fraction. Alright, now, and we know that 35,000 joules every second is the useful energy transferred. So the question itself gives you the values. All you need to do is just substitute them into the equation. So what we're going to do is we're going to write efficiency down. So we're going to write that down nicely so that you guys can see it, how it works. So you have efficiency is equal to the useful energy transfer, which in this case is 35,000 joules. 35,000 joules divided by 175,000 joules as well, which is the energy that is supplied. Now you're going to put an equal sign again. You're going to divide using a calculator. Use the calculator in exam. It's going to help you a lot for the exam as well. As you guys can see it is about 0.2. Now efficiency, sometimes they might ask you to give efficiency in terms of percentage or in terms of decimal. It doesn't matter what it is. Usually I would give it in a form of percentage, as I know it is better. So I'm going to times it by 100 to give us a value of 0.2 times 100 to give us a value of about 20%. But it doesn't matter if you leave it as 0.2. That's one bonus tip you guys can take from this, is that depending on the question, what they're asking, if they're asking you to give it in terms of percentage, you have to times 100. You have to times the answer by 100 to make it in terms of a percentage. And in this case, we know that efficiency is about 20%. So 20% is going to be your efficiency in this case, okay? Depending on the question, if they ask you to give it as a decimal, leave it as a decimal. If they ask you guys to leave it as a percentage, just leave it as a percentage as well, okay? Now, what happens to the energy that is not usefully transferred by the solar cells? Like I said, no machine is 100% efficient, so they're either going to transfer this form of energy into useless thermal energy stores. So you're going to say it's just going to be wasted. That's it. That's your answer. For 1 mark, you just got to write down wasted. Or you can say it's just transformed to heat, or it's just transformed to the air surroundings. That should be fine as well. But just say it's wasted. It's wasted energy. That's all. Let's move on to the next question. Next question states that the aircraft propellers are driven by electric motors, as well as the solar cells. There are fuel cells that provide additional power to the electric motors. Now you have to suggest one advantage of the aircraft having fuel cells, as well as the solar cells. Now, one advantage is that solar cells don't work at the night, so it can help to fly at night. Can help the aircraft, let's say, fly at night. That could be one answer you could say. Say fly at night. Other answers you guys can mention is that it can stay longer in the air, it can fly in winter, or it can fly faster as it is additional power. Second question states that you have to give one environmental advantage of using electric motors to drive the aircraft propellers rather than motors that burn out fuel. Now, one environmental advantage is that there are no pollutant gases produced. No pollutant gases. No pollutant gases produced. So this is one answer you guys can write. There is no pollutant gases produced. You can mention that there's no greenhouse gases. You guys can also mention that there's no air pollution. That should be fine as well. All right. And yeah, you can say that it produces less noise, less demand for fuels. You guys can mention that. Since it's only for 1 mark, you guys can also mention 1 point. So on the third question. Eventually, the designers want to produce an unmanned aircraft that can fly, let's say, at twice the height of the passenger jet for about 6 months. So just one possible use for an aircraft such as this. So why they want this type of aircraft is that we can say it's maybe for weather forecasting, so that it can fly twice as high as the height of the passenger. It could be for analyzing weather, so you can mention that it's for weather forecasting. All right, for weather forecasting. All right, or it can be mentioned for spying or to map the Earth's surface. It depends. Or it could be used as a satellite itself. So that's 1 mark. You guys can write down. So 12 questions for about 6 marks. Let's move on to the next question. Now the next question shows us a nice little diagram as well. Now this is showing us that the picture shows a temporary road traffic information board. The batteries power the LEDs using the information board. The solar cells keep the batteries charged. Now what you're going to do is you're going to use the words from the box to complete each of the following sentences. So the solar cells transfer light energy to, you're going to mention that it's going to transfer light energy to electric energy. The batteries, they transfer the chemical energy to electric energy. The LEDs transfer the electric energy to light energy. That is it. That's about it for this type of question. All right. Electrical, chemical, light. Let's move on to the next question. Next question is a calculation question. So when the total energy input to the solar cells is 200 joules, we know that this is the energy input. The useful energy output from the solar cells is about 50 joules. Now the efficiency, they have not mentioned whether it's percentage or it is the decimal form. So we're going to say that efficiency is equal to useful energy transfer. That's about 50 joules divided by the total energy supply. That is the formula of efficiency. Total energy supply, that's going to be about 200 joules. All right. So what we're going to do is we're dividing the useful energy supplied by the total energy input. All right. So 50 divided by 200 is going to be about, let's say, 0.25. I would like to convert it to a percentage. So you have times 100, 0.25 times 100. to give you a 25%. I'm just going to rub this 100% symbol off. So it's 0.25 times 100 to give you a 25%. That could be your efficiency. You guys could leave it as 0.25, but I like to leave it as a percentage just like it is. So 25% is your efficiency of the solar cells. Let's move on to the next question. The next question is more like a tick the box situation. Alright, so which one of the following statements gives a reason for using solar cells to charge the batteries? Solar cells will charge the batteries day and night. At night, this is not true, so you're not going to mention this part. The information board can be used anywhere it's needed. That seems like a reasonable choice. A small number of solar cells produce a lot of electricity. This is not true as well, so you're going to mention this. You're going to tick that portion there. The information board can be used anywhere. That seems to be the most reasonable choice among this list. Alright, let's move on to the next question. That's total for 6 marks. Now the next question shows us, this is similar to the electricity chapter questions, is that in Britain most power stations burn fuel to produce heat. The diagram shows the stages by which the heat is transferred into electric energy. Now you have to complete the diagram by filling in the missing word. Now the water heated to produce a steam causes the steam to turn the turbine turns a coil in a generator. So you're going to mention it is going to be in a generator and the electricity is produced. Alright, now next part is that a fuel burning power station uses about 2,000 joules of fuel energy to generate 600 joules of electric energy. So this is a question that asks us how much fuel is wasted as heat. So you know that the fuel burning power station uses about 2,000 joules of fuel energy to generate about this much amount of electric energy. So what you're going to do is that you're going to have 2,000 joules. I'm going to write there down J there minus, it's going to be subtract 600 joules. Now this is going to give you a value, since we know that the useful energy combined with the wasted energy makes the total energy supply, right? So yeah, we know that 2,000 minus 600 is about 1,400 joules. Now this is going to be our answer for about 1 mark. Now you're going to calculate the efficiency of the power station. We know the efficiency formula. If you guys want me to write it down, I'm going to write it down for you guys. Let's just reload the system again just to check. So efficiency is equal to the useful energy divided by total input energy. Okay, this is the nice little formula you guys can remember. Your useful energy in this case is about 600 joules. From the question I got it, divided by the total energy supplied is about 200 joules. I'm going to multiply this by, I'm going to leave it as it is. So you have 600 divided by 2,000 joules. 600 divided by 2,000 should give you a value of about 0.3. I would like to convert it to a percentage, so I'm going to write times 100. It's going to be equivalent to about 30%. You guys can leave it as a decimal if you guys like. I'm going to leave it as a percentage again. So you have 30%. That should be your answer for 2 marks. Alright. Now efficiency states that list A gives 3 energy resources used to generate electricity. List B gives the environmental problems that may be caused by using different energy resources. Draw a straight line from each energy resource in list A to environmental problem it may cause in list B. Now draw at least 3 lines. So you know that list A has the energy source. This is the environmental problem. We know that wind produces a lot of noise, so that could be one of the issues of wind. Energy, tides. We know that tides destroy the habitats of wading birds in river estuaries. We know the falling water falling water floods land used for farming or forestry. That could be one of the disadvantages in this case. That's for 3 marks. Let's move on to the next question. Now the next question shows us a graph that looks like this. That's an unusual graph, but looks like that. So a small wind generator is used to charge a battery. The graph shows the power output of the generator at different speeds. Now you guys can see that there's a power output in watts in the y-axis and there's a wind speed in the x-axis. That's something that you guys have to analyze. Now you have to understand what is the maximum power produced by the generator. As you guys can see, the graph is curving upwards and it's stopping at a point of about, let's say, about 8 as the wind speed. So stopping at the wind speed of 8, so it's generating about maximum of, let's say, if you cross it at 8, that's about 110. So that's the maximum power it can produce in watts. Alright, let's Let's move on to the next question. Is that the generator is designed to stop if the wind speed is too high? At what wind speed does the generator stop working? So the generator stops working at a wind speed of about 12. That's where it stops. As you guys can see, there's a horizontal line there. That's where the wind speed stops of about 12. All right. So it's going to stop at a wind speed of about 12 meters per second. Now, give one disadvantage of using a wind generator to charge a battery. One answer that I would like you guys to write is that wind is an unreliable source of energy. So you can say that wind is an unreliable source of energy. You guys can mention that. Or you could say that the power of the wind generator, depends on wind speed. Depends on wind speed. Now this is something that you guys can write down for 1 mark. You could also mention that wind may not always blow, and you guys can mention it does not generate if wind speed is too high. You can mention that wind is an unreliable source of energy, and you can mention some values as well if you guys like. Let's move on to the next question. Now the next question shows us that a person uses a stair lift to go upstairs. The stair lift is powered by an electric motor. Now this is a Sankey diagram, by the way. Sankey diagrams are like these grid-like structures. They're used for efficiency, displaying efficiency, transfer, and all that stuff. All right. You guys can see the electric input energy. You guys can see the useful energy, and as well as the wasted energy. Now the wasted energy, one useful tip here is that the wasted energy combined with the useful energy is the total electrical energy input. All right, so that is your answer. Now you're going to say that the electric motor base energy as, let's say, thermal, all right, as thermal energy or heat energy in this case, or as sound energy. Just like I said from question 1 itself, that no machine is 100% efficient, as they waste energy in the form of heat, sound, and thermal energy. All right, let's move on to the next question, which states that the efficiency, we have to calculate the efficiency of the electric motor. We know that the efficiency is going to be equivalent to the useful energy transferred by the device. The useful energy here in this case is about 2,000 joules. So 2,000 joules divided by the total energy supplied by the device. This from the question is about electric energy input of about 5,000 joules. So this is 5,000 joules. You're going to divide 2,000 joules divided by 5,000. That's going to give you a value of about 0.4, which I'm going to multiply by 100 to give you a percentage of about 40%. Now this is going to be your efficiency for this case. All right, where I got this 2,000 and 5,000, I got this from the Sankey diagram. It clearly states that the electric energy input is 5,000 joules and that the useful energy is about 2,000 joules. And we know that efficiency formula is equal to useful energy, that is this useful energy, divided by the electric energy. All right, that is your efficiency. Now this guys seems to be the end of the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video and whether I should continue solving topic related questions or past paper related questions. And yeah, I think that's it, guys. New content will be posted soon. Do check out the time codes below in the description box, so you guys can skip to the questions as you guys like. And if you have enjoyed, do stay motivated, and yeah, have fun. I think that's it, guys. All right, bye, guys.